In this video, we're going to be learning the naming system of the counterpart to ionic compounds, that being covalent compounds, which, for those that do not recall, are distinguished from ionic compounds by the simple virtue that they do not have any ions in them. So, for example, NaCl, the chemical formula for salt sodium chloride, is definitely not a covalent compound because it is made up of a metal ion and a non-metal ion. Now, one of the easy ways to identify a compound as being covalent by simply looking at its chemical formula is that covalent compounds will never have any metals within their chemical formula. Now, there are actually more complicated ionic compounds, such as this compound here, which is called potassium nitrate, and we can see that this definitely isn't a covalent compound because it has a metal ion in it, but instead of a single non-metal ion, it actually has a group of nonmetals, that being nitrogen and oxygen together, and together these two have a negative charge. This is a type of ion that we call a polyatomic ion, but again, since covalent compounds are not ionic, the presence of a polyatomic ion like this will mean that it isn't a covalent compound. So the distinction between ionic compounds and covalent compounds is in their formation. Remember that an ionic compound forms when a metal loses its electron and when a nonmetal is there to receive that electron, and that allows each of the metal and nonmetal to form a charge which then attract to each other in order to form the compound. And covalent compounds do not form like this at all. Instead, they form by sharing electrons instead, and this will be explained in future grades. For now, we can learn the naming system, which actually begins identically to the naming system of ionic compounds. That being, if we take a look at the two nonmetals, the first thing that we need to do is use the periodic table in order to identify the name. So all of our covalent compounds in this video will all be named based on the elements nitrogen and oxygen, chemical symbols N and O, respectively. So the chemical symbol N is the symbol for nitrogen, and the chemical symbol O is the chemical symbol for oxygen, and the third step is even identical to naming ionic compounds. We take the suffix of the second nonmetal in the formula. So in this case, the second nonmetal in all of our chemical formulas here is always going to be oxygen, at least in these cases here, and we're going to take the suffix of oxygen, the -gin part, and replace it with the same three letters, IDE. Now, in this case, we leave the name of the first nonmetal, nitrogen, intact, and then we replace the suffix -gin in oxygen with IDE, and then we have nitrogen oxide. Now, the problem about just naming any compound here, nitrogen oxide, is that all of these different chemical formulas would all have the same name because they're made of nitrogen and oxygen. And this is what makes covalent compounds different, is depending on what the two nonmetals are, you can actually make many different covalent compounds depending on the number of the first nonmetal or the number of the second nonmetal, whereas this is impossible with ionic compounds because the charge of the metal and the nonmetal need to balance out completely, and so there is only one combination of metal and nonmetal ions that can come together in order to make an ionic compound, but this is not the case with covalent compounds. So to distinguish which nitrogen oxide is different from the others, the next thing that we need to do is add what we call numerical prefixes. Remember that a prefix is a section of or a combination of letters that we add to the beginning, because pre is the prefix for before or at the beginning. So we need to add a numerical prefix to the beginning of each of the metal or each of the nonmetals in our formula in order to identify how many of each nonmetal we have. So if we start with the simplest nitrogen oxide, NO, we simply begin with nitrogen here. Now, in order to identify this, we need to first identify what our numerical prefixes are, and many of these will be familiar. For example, the prefix that means one is the prefix mono. For example, a train that travels on one track instead of two is what we call a monorail. The prefix for 2 is di. The prefix for 3 is tri. For example, a version of a bicycle that has 3 wheels that children in primary school ride around on are what we call tricycles. The prefix 4 is a little bit tricky to remember. The prefix tetra means 4, and the best way that we can help remember the name tetra is if we have a 4-sided pyramid where every single side of the pyramid is a triangle. This shape is what we call a tetrahedron, meaning that it's a shape that has 4 faces or 4 sides. The prefix for 5 is penta, and the easiest way to remember this is remembering what a 5-sided shape is called. This is what we call a pentagon, and this applies to a number of other shapes here. For example, a 6-sided shape is called a hexagon, a 7-sided shape is called a heptagon, an 8-sided shape is called an octagon, a 9-sided shape is a nonagon, and a 10-sided shape is a decagon. So these are the numerical prefixes, and if you have trouble remembering them, my recommendation is just to say them really quickly, one after another. So mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. When you can do it at that speed, try saying them faster. Mono, di, tri, tetra, penta, hexa. And we can see that I'm tripping over my own words. Mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca, until the act of saying them helps you commit them to memory. So now that we have our numerical prefixes, we can begin to modify the name nitrogen oxide. So as a little bit of a disclaimer, typically we only use the prefix mono, meaning 1, for the second element in the chemical formula. So in this case, we would not use the prefix mono for nitrogen. If we don't write the prefix mono, it's implied that there is only one of the element. But we add the prefix mono here. Now, you'll notice this is a bit of a spelling convention here, because if we were to write the name like this, it would be pronounced monooxide, and this is a little bit of a spelling convention for English. English doesn't usually allow consecutive vowel sounds like this, monooxide, so instead we merge the two sounds together and just pronounce this monoxide. So, nitrogen monoxide is a covalent compound that has 1 nitrogen and 1 oxygen. If we take a look at the next example here, now we need to use the numerical prefix di because there are 2 nitrogens. So this is what we would call dinitrogen, and because there's only 1 oxygen, we write the word monoxide, or we add the mono prefix and fuse the 2 O's together to make monoxide. Then if we try example 3, there's no second nitrogen here, so we don't need to add the mono prefix, so we just write nitrogen, but since there are 2 oxygens here, instead of adding the prefix mono, we would use the prefix for 2, di, and simply add that to oxide, and yes, it is written as dioxide. So remember that rule about English not allowing consecutive vowel sounds? Yeah, well, English doesn't really listen to its own rules. Funny how that works, because dioxide are indeed consecutive vowels, but this is the spelling here. If we take a look at example 3, we have 2 nitrogens, so this would be, excuse the miswriting there, this would be dinitrogen for the 2 nitrogens, and then we would use the prefix tri here to indicate that there are 3 oxygens. And again, English doesn't follow its own rules about consecutive vowel sounds, so this is indeed written as trioxide. Then if we go down to example 5 here, 2 nitrogens is again dinitrogen. But since we have 4, we need to use the prefix tetra, but here English decides to follow the cannot allow 2 consecutive vowel sounds here, and so the way that we would actually spell this is tetroxide rather than the rather annoying to say tetraoxide here. So again, we would fuse these 2 vowels together like this. And for our final example, again, 2 nitrogens, so we use the prefix di before nitrogen, and for 5, we need to break out the prefix penta here. But once again, if we follow the consecutive vowels rule, instead of writing out pentaoxide like this, we would fuse these 2 vowels together, and we would just pronounce this pentoxide for dinitrogen pentoxide. So once again, the rules for naming covalent compounds are actually very similar to those of ionic compounds, just with the addition of numerical prefixes, because once again, depending on which nonmetals form a compound together, they may do so in different numerical combinations, hence using the numerical prefixes to distinguish one form from the other. So this concludes our short series on naming ionic and covalent compounds. To make sure that you understand how to use the numerical prefixes, you can try the practice problems in the table of compounds below. And of course, remember that every single one of these is a covalent compound, so be sure that you are applying the correct numerical prefix in order to identify how many of each nonmetal you have in the compound.